Client-side virtualization. The virtualization technology has many benefits to it. We can have virtualization on the client side and have a host machine that hosts many different operating systems on that host machine. And these operating systems can be different operating systems than the host machine. You can have a host window machine hosting a Linux virtual machine, or older variations of Windows operating systems. Virtual machines on a client system can give us a lot of different possibilities of different combinations to run multiple operating systems. When we look at virtual machines, again, the physical machine or the host machine can host many different operating systems, and they can run at the same time. The host machine and the virtual machines are independent of one another, meaning that the host machine is just the host. Each virtual machine can act independently of the host machine. Each machine has its own operating system and its own resources. So it's almost like mini computers or systems on that host machine. So you have the workstation with other virtual machines on that host. So you can use in a virtual machine or a client-side virtualization, you can have a desktop with multiple operating systems, or you can have a dedicated server that runs separate operating systems as well. The key to desktop virtualization is the hypervisor, also known as the virtual machine manager. The hypervisor is the element that sits between the virtual machine and the host machine, and it supports the virtualization. It controls and manages operations. It manages the CPU, the security, and the network. And the host machine would have to support virtualization in order for this to work. As you can imagine, there's a lot of hardware requirements when it comes into place for virtualization. First of all, you have to make sure that your CPU supports virtualization. In Intel, you want to make sure that you're using the virtualization technology type of CPUs or the VT. In AMD's, it would be the AMD-V. Check with your manufacturer of your processor of your CPUs to ensure that that technology can be supported. And then sometimes that technology has to be enabled in the BIOS. Again, check with your manufacturer and it can show you how to and what steps to take to enable virtualization. And again, for the hardware requirements, you're going to have to make sure that your host machine can host the memory for itself as well as the virtual machines. The disk space. Each virtual machine has its own disk image plus storage. So you have to make sure that host machine has enough storage to house storage for itself as well as those virtual machines. The network for the host machine and the separate virtual machines will have their own separate configurations. They're going to be standalone, NAT, or bridge. We'll talk about those here in a little bit. And these are all controlled by something called the virtual switch. You can do advanced configurations in a virtual switch, VLANs, and different network settings and configurations. One thing also you need to consider when you're doing desktop virtualization is security. Virtualization is a target for attackers, so you have to make sure that your system, your host machine, and your VMs are secure. Now, currently, there are no known vulnerabilities with virtualization. But however, there are some things that you need to be aware of. For one is VM escaping. Malware is loading onto the host computer and it compromises the hypervisor, then moves to the guest OS machines. Now, and this is something you want to be aware of because in an environment, if you're using a virtual machine in a hosted environment, this is something you have to be aware of because of that hosted environment. It is a target for attackers. And as well as network requirements, you have to be aware of and how to configure virtual machines for the network. There are several different ways you can configure a VM. The bridge network access. The VM is a device on the physical network, so that it's the same as the host machine. It's on that physical network if you set it up in the bridge network configuration. You can also do a shared network address where the virtual machines uses the same IP as the host. It uses a private IP address internally, and it also uses NAT to convert to the physical host IP. And you can also have what's called a private IP address. And in this configuration, it does not communicate it with the outside world. That VM is private and it does not communicate with anything on the host network. Application virtualization is another benefit for desktop virtualizations where developers can use application development right on a virtual machine. Certain situations lends to this. Specific applications have to be on a certain OS. Again, those applications could be OS specific, or the programs that you're running could be OS specific. And that's another reason why you want to do development on a virtual machine. Also, another key benefit, you can run several instances at the same time. You can save time and resources and hardware by working in a virtual environment for your development. Another key reason and benefit for virtualization is legacy software or operating systems. Imagine that you have a application or software that can't run on newer operating systems and have to run on an older operating system. So therefore, you can spin up a VM of an older operating system and run that legacy software or that application. In another scenario, you can run multiple application versions on the same host but different VMs. For whatever reason, you may have a scenario where that application has to run many instances. So that's another key benefit for using a virtual environment to do that in. Cross platform virtualization. One OS can't do everything. And that's why it's a very good sometimes to have different operating systems on a host machine. On that host machine has its own operating system, but on the VMs, you can have Linux, you can have Windows. You can have the host machine as a Mac, but run Windows on a VM and Linux in a VM. And certain operating systems have certain key benefits or programs or applications that they run. So it's good to have the virtualization where you could run different operating systems because, again, one operating system can't do everything. You may have certain features of one particular operating system that you can't get from others. Another reason to use virtualization would be a sandbox for application development. Say for instance, if you have a developer who's developing a certain code and they need to keep it secure from the production environment, they can put that in a VM or virtual machine. And that way, that isolated environment does not contaminate the production world. With with backups and rollbacks, virtual machines have those built in automatically. You can easy make a backup or roll back your changes. If you make a change and need to go back, you can roll back in a VM. And not only with that one application, you could actually simulate a whole production environment before you get to the real environment in virtual machines. The application could work with a simulated production environment, and you can test and make sure that that application will do everything it needs to do before you take it out on the real world. Test development is another area as far as development and virtual machines. Secure platform to code to develop your code in. You can create an entire testing environment for the code right in a virtual machine. All right, in this lesson, this is the key things that we covered in this lesson. We talked about really the purpose of virtual machines. We talked about the resource requirements and the security requirements. And in the area of development, how you can use virtual machines, talking about the application virtualization, sandbox, and test development. All right, that is it for this lesson. We will see you again in the next lesson.